All right, this is for the con assignment, number of solutions to a system of equations graphically. All right, the last one we did was algebraically. Okay, and if you want to do this one the same way, you certainly can. To be honest with you, it's probably easier to do it algebraically than graphically. All right, but if you want to have fun with this graph, I'll show you how to do this. It's very easy. All right, if you want to play with the graph a little bit, what you want to do is you want to plug in 0. You want to plug in x equals 0 and then y equals 0, one at a time. All right, just to make the graph. So looking at we'll call this one equation 1. All right. So we'll do equation 1 right here. So at x equals 0, if you put a 0 in here for x, you get negative 2y equals 8. Okay, and in that case, y would be negative 4, because negative 2 times negative 4 equals 8. So y equals negative 4. When you plug in x equals 0. Let me see. X equals 0, y equals negative 4. All right, so if you go down here, x equals 0 is your y-axis, and y equals negative 4. So I'm going to have to move this out of the way here. On the bottom one, go to y equals negative 4. At x equals 0. Okay, and you have to do the other point as well. So I'm going to have to do y equals 0. Okay, so for equation 1, I'm going to have to do y equals 0. And when I put in y equals 0, this cancels, and I get 4x equals 8. And of course, x will be 2, because 4 times 2 equals 8. So at y equals 0, x equals 2. Okay, so let's take the same line. Y equals 0 is the entire x-axis, and x equals 2. So we just go right there. All right, so we got the first line. And now we have to do the second line. All right. So from equation 2, I might as well do it in a different color. All right, equation 2. First, we'll plug in x equals 0. Okay, if you put a 0 in here, this will cancel, and it's just y equals 2. And then I'm going to plug in y equals 0. Okay, if I put a 0 in here, this will cancel, and I get 2x equals 2. And obviously, x is 1, because 2 times 1 is just 2. All right, so going to the graph, x equals 0, y equals 2. So now I'm on the other line here, okay? X equals 0, y equals 2. All right, so that's right here. Okay, x equals 0, y equals 2. And then the other one, x equals 1 when y equals 0. So I go take the other point and go to x equals 1 at y equals 0. Okay, and we can clearly see right there the two lines intersect, right? The two lines intersect at that one point. So it's exactly one solution. Okay. Now, do you have to do it this way? Absolutely not, okay? I think it's actually more work to do it this way, all right? You can if you want to, or maybe just one problem just to prove that it works, okay? But nevertheless, you can do these algebraically, all right, just like we did the last exercise. So either or will work just fine, okay? I think they just wanted to prove it to you that the graphs would work. But if you want to do it graphically, it's going to take a little bit longer. but that's the best way to do it. You plug in x equals 0 and y equals 0, one at a time, in each of the two linear equations.